Okay, it's just three of us, and let me make sure. Can you hear me?
Yes.
Okay. All right. So what I will do is I'll first go over homeworks 4 and 5, and then if you have other questions about some other stuff, I'm happy to take them. So homework 4 was on decision trees, and that's another supervised learning technique. And the context for your homework was spam detection is a very common application of classification. And so that was the context. And so you're given a data set, it had no missing values. So the different parts that you had for the problem, there were two sort of broad segments. In the first part, you were asked to use all the variables that were there in the data set, create a decision tree, rather generate a decision tree with the default parameters, and then analyze the predictive performance of the model, and then comment on what you see, if you see any issues in terms of using the model for spam detection. And then in the second part, you were asked to use, you sort of had to ask to trim the model and use the top 5 predictors and basically do the same thing and generate the decision tree. What is its performance? And then you were asked to compare the two. Okay. And then there was a qualitative question about what's the basic limitation of this kind of model for spam detection. And and then the second and the third part was you had to optimize using grid search and all that. So the second question is qualitative. So I'll go over that. So as I review, debrief you, as I usually do, I will just what I did was I picked out segments of answers from different teams. And I use that to give feedback in terms of good answers, not so good answers. So you get a sense of, you can compare your answers to what I viewed as a strong answer, maybe perhaps not so strong an answer. So the process model was pretty much good for all teams. There was no issue there. You retrieve the data, and then you set the target variable. Since this is supervised learning, you always have a target variable. And this was the spam, not spam column. Then you split the data into training and validation data, performance evaluation data set. Then you generate the decision tree with its various parameters, and then feed that into the training, the evaluation data set, and then it computes the performance. So the performance part computation is no different from logistic regression. Okay, after all, it's a classification problem. So you have the precision, recall, sensitivity, and all of that stuff. Now, there were a couple of teams that had an operator here called select attributes. So right after they retrieved the data set, they had select attributes and then set row. So I'm not quite sure what that operator was doing, because all the columns that were given to you were needed for the decision tree. So I'm not quite sure what was going on there, but I saw that they had all the variables in the output, so it's not like they lost a variable. So I'm not quite sure what that operator was doing there, but I don't think you need that for this problem, the way the data was given to you. The so the top 5 predictors. Now, one thing I need to point out is the top 5 predictors that you would get, in other words, the decision tree that you get, is very sensitive to the actual data that's fed. That's one of the weaknesses of decision trees. So if you get a slightly different data set, it might come, the tree might perform just as good, but the tree itself can be different. So when I went across different teams, I saw slightly different sets of 5 top predictors, and which is perfectly fine. Okay, but the main thing is how to come up with the top 5 predictors. And when you look at the decision tree, so this is the tree sort of turned on its side. You just go from the root. The root is the leftmost level. That's the root. And you start from the root, and that will have branches down, and you go to the next level. Then you go to the next level down, and you pick the top 5. Now, so the first you can see here is C underscore count of exclamation mark. So this decision tree here that you see doesn't correspond to the choice. This is from a different team, but I'm just trying to explain how the top 5 will be obtained. So that's how this this C exclamation mark you see is one of the variables that was chosen. Then if you go down, so if you go down the tree, this is kind of, it's a big tree, so it's a little bit difficult to follow. But then if you go down one level, it's one to the right, that's basically what it is. Then you go down to level 2 and you see W remove equals false. So remove the that particular word. And then you go down the second level, you probably get 2 of them, and that will give you 2 more. You go down one more level, you'll get maybe 2 or 3 more. And then sometimes, in this case, what could have happened, I think it may have happened to one team, is that on one level, they ended up with 3. And so they had to choose one of the variables out of the 3, because I asked for 5. And there are certain criteria that you can use. You can trace down the subtree and see which one is a little more pure than the other, and pick that. But the basic process is start from the root and then start picking the variables as you go down. So those are they will give you the most significant variables for doing your decision making. Visually, some teams presented the decision tree better than others. In some cases, maybe they were trying to fit it into one page. It was very difficult to visually see it, but it was okay. Here, for instance, I can see. So even when I blow it up, it was sometimes difficult to see for those for some of the trees. So now, so the first, what are the top 5 predictors, and the printout of the decision tree? In most cases, it was fine. When it came to the discussion of the performance, here's where there were differences in quality of answers. So I'm just showing you 2 different answers from 2 different teams for performance. Okay. And what makes for a good, one thing is there were several teams that did not put the confusion matrix. Okay. They discussed the numbers and they wrote it, but there was no confusion matrix. I need to see the confusion matrix just to make sure that you're not interpreting terms incorrectly. So terms like sensitivity, recall, and so forth that are used in the narrative, when you say sensitivity such and such percent, recall such and such percent, which may be perfectly fine, but I also need to do a check that it's been interpreted correctly. So when I see the confusion matrix that comes out from RapidMiner and you stick it there, and then you use that as the basis of the narrative, that makes it a lot easier for me to check, yes, this is the correct interpretation. Okay. The other thing is that there were some discussions that were just purely technical, meaning the sensitivity is so much, the recall is so much, so it's good. Okay. I think the narrative for any context, whether it is spam or some other classification context, it's always useful to the reader to present the performance in the context of the problem. So that high sensitivity of 91%, what does it mean? Okay, that you're letting in what percentage of spam is let in, what percentage of non-spam is let in. So these, so explaining the performance or discussing the performance in the context of the problem is always more digestible, rather than just saying it technically that this is the sensitivity, this is the recall, hence it's a good classification algorithm. So that was sort of the difference between the better answers and all the answers were good, and there was nothing wrong with the answer, but some of the stronger answers did a better job of discussing the performance in the context of the spam and the application itself. Okay. Okay, so one group presented I think more than one group, I shouldn't say one group, actually presented the confusion matrix and then used it as the basis of discussion, but not all groups did that. So I just wanted to point that out.
Professor, could you walk through the specificity and precision and how you explain them in context of this spam?
Sure.
I get turned around, I think.
Okay. So look on the right-hand side, this is the spam, right? True
Right.
one. Now, I picked this up from some, I don't know which team. And can you remind me, was
Yeah,
one,
I think 0 is the spam and one is the
one is the
non-spam.
non-spam. Okay.
Right.
So let's take on the spam side. You have this 94.4% sensitivity. If you look down the column, right? So it's 793 divided by 793 plus 47. That's where the 94% came from. Okay. That means out of all the actual spam emails, the decision tree was able to identify 94% of them correctly. So it led through 94% of good emails. So that's the physical interpretation of that. Okay. Now let's look on the row side. Again, we'll look at 0, which is spam. Okay. So here you see 92%. That means out of all the emails that the classifier said, here are all your spam, this is what I think is spam, 92% of them actually turned out were actually spam. Okay, because think about this, you could cast a very wide net and you would never miss anything. But in the process, you would be collecting a lot of junk also, right? So sensitivity and precision are sort of, you want both of them to be high. And usually the problem is you can't, here is a situation where you've done well on both counts. But that sometimes doesn't work out that way. Okay. So if you make your filter very loose in the sense that anytime you have the mildest suspicion that an email is spam, you classify it as spam. Then what happens? You'll hardly ever miss a spam. But a lot of emails that are not spam, you will classify as spam. And if your email is set up to direct spam to some other folder, then the reader might not see the emails and say, oh, go check. That's why you get these things, which is go check your spam folder, maybe it's over there. So that's the danger of performing badly on one dimension or the other. So, but from a class standpoint, from my teaching standpoint, whatever discussion, even if it was a very technical discussion, whether those numbers were interpreted correctly, I need to see the table. Okay, and there were a couple of instances where the table was not there and the discussion was there, and I couldn't tell. Okay. Okay, so the second part, let me just remind myself of what this 5. Okay, there's a 5 topic. So the second part is basically doing the same thing. I didn't copy trees which were trimmed. Okay, I was mainly looking at the discussion of the performance. So again, my same comment about discussion of performance for the trim model. I would have liked to see the confusion matrix and then a discussion of sensitivity, precision, what have you, in the context of the spam application. So the main thing in the second part is the comparison with the first. Okay, so here I have a comparison, and it's fine. I mean, when I read it as a narrative like this. So again, if the in both the parts, if the confusion matrices were not there, it makes it a little hard to interpret it. But even if it was there, when you do a comparison of performance of the full model with the trimmed model, it always helps to do it in a tabular format. So let's say you have sensitivity, recall, and so forth, full model, trim model. Then it's very easy to map the two and see where the performance has improved, where the performance has not improved or has decreased. Okay, and doing it in this narrative form is, I mean, there's nothing wrong with it, but it's a little hard to digest. I think there was one team that put it in tabular form, if I remember correctly, just nicely tabulated, full, partial, and all the performance metrics. So that's my general feedback about part 2. Part 3, again, there was really not that much. So part 3 was where you had to do a grid search. And how does the performance compare to the trim model? It is not that much of an improvement in performance that you would have seen, but the discussion would have been pretty much the same. So what I was looking for there, I didn't see any team that did anything wrong or inaccurate for part 3. Again, it was the discussion of performance that was where I would take that I found was different across the teams. So now coming to question 2. So at sobriety checkpoints, what kind of questions would you ask before you send them to a field test, the breath analyzer test? So there were various suggestions, and most of them make perfect sense. Okay, there were a couple of teams which said, okay, so for example, what is the subject's blood alcohol content based off a field test? That cannot be a valid question, a valid answer to the question that I gave for part 2. So this is a sobriety checkpoint. Every car is stopped to determine if there's evidence of driver impairment. Police officers look for signs, ask questions. If they conclude the driver is impaired, they are pulled over for a test. So these are the questions before the test is done. That's what I'm asking. What kind of questions would you ask? So in the answer to this question, if a team says that what is the subject's blood alcohol level, that's not an appropriate. I mean, it's fine for the situation, but it's not an appropriate answer for that part of the question. But there were, most teams got many of those questions right. So let me see. So does the subject appear to be struggling with operating the vehicle? Do they appear to be the bloodshot eyes? They have a smell of alcohol on their breath. These are standard signs that one look for. Okay. Or does ask directly, when was the last time that you had a drink? So there were all reasonable questions in the list. There was really, I accepted pretty much anything that sounded reasonable. But again, there were a couple of teams that had this. What is the blood alcohol level? And that's not an appropriate answer for that part of the question. Okay, is the subject's speech slurring? Here's just some examples of, are they exhibiting unusual behaviors, such as dropping keys? Fine, okay, that's all. I suppose that's fine. Okay, so the second part of question 2, between the 2 classification methods that we have studied, for one was the 2 contexts. One was apple sorting, and the other was pick sickness detection. You had these 2 questions settings in the previous assignment as well, where you were doing logistic regression. So now that you know 2 different methods for classification, I wanted you to think through, when might you use one versus the other? Are there circumstances where you use one versus the other? So, I was pretty much willing to accept either one, as long as the justification was fine, was consistent. Now think about so for instance, for apple sorting, one of the answers that I got was use decision trees. I mean, and the justification given for it was that decision trees, the decision that they make are easier to explain, because there are rules along the way. You know what the branches were made to get to the. So it is easier to explain the decision. That is technically absolutely correct. But think of the apple sorting application. These apples are zipping through a line in few seconds. There's a machine that's looking at them optically and just sorting them. This question of explaining your decision doesn't really arise at all. Explaining your decision arises more in a managerial context, where you have arrived at a decision. You have to explain it to some other humans. Why did you do this? Why didn't you do that? that is more relevant in a managerial context. In a machine sorting setting, explaining your decision for every apple, why did this apple get sorted, why didn't that get apple, is not so relevant. So that making that a justification for using decision trees doesn't sound so strong. Now, and it's in the case of the pig sickness detection, okay, maybe that, since corrective action would need to be taken to treat the pigs, some kind of explanation might be necessary. Why did we arrive at this decision of a diseased pig? The farmer might want to know. But so in either case, whatever answer was given, whether it was decision trees or logistic regression for either context, I was happy to accept it as long as the explanation was went along, the justification went along with the choice. Okay. So again, I'll point out some explanations that don't sit so well. For example, decision tree analysis will work with this kind of a large data set. That, logistic regression will work perfectly well with a large data set also. So if somebody makes a statement that, yeah, we prefer to use method X because it works well with a large data set, then I immediately ask myself, so, okay, then the other method doesn't work well. You're implying that the other method doesn't work well with the large data set, and that's not true. So I think some of the justifications, you have to be careful about how you use terminology and what justification you put forward for the choice. Okay.
Is there some rule of thumb where you would use a decision tree versus regression?
Logistic regression?
Sorry.
Oh, absolutely. I mean, rule of thumb meaning, okay. By the way, before I forget, there was something I wanted to mention in the previous for the spam application, and one of the questions was which model would you choose, the trimmed or the large model? And if I remember correctly, the trimmed model performed a little bit worse than the full model, which is not surprising. But one thing that I didn't see, perhaps I'm a little bit surprised it didn't occur to any team, that this is a real-time application. You're classifying emails on the fly as they come in. So the speed at which you operate, you don't have a whole lot of time. You're scanning the email, it could be a long email, and you have to classify very quickly. So the complexity of the decision tree matters. If you have a very large decision tree compared to a small one, which perhaps performs marginally worse, but it would be a lot faster, then the filter wouldn't jam things up. That's all. So that's another factor to consider in your choice of trim versus not trim. Anyway, Donita, coming back to your question about, is there some general rule about decision tree? Number one, if a lot of your independent variables are categorical, then decision trees are good. So in the case of the spam application, a lot of your variables were quantitative, if I remember correctly. There were counts of various things. Okay. So in general, if a lot of your independent variables are qualitative, then decision trees work well. Okay. The other thing is, if you have to explain your decision, and this is in a managerial context, that let's say a major decision was made, what is the logic behind it, then the decision tree is good for that. With logistic regression, you don't have that kind of transparency as to why. It's all numerical because this coefficient was significant. That's why we chose this. So that is a harder sell in a managerial context. Okay, so a decision tree is better for that setting.
Okay, thank you.
Okay. All right, let me move on now to assignment 5. Oh, where's my feedback document? Just give me 1 second, please. I seem to have lost my feedback document. Hmm? Ah, here we go. I knew I had it somewhere. Okay, can you see the document? Okay, good. Okay, so for this was a clustering exercise, and this is the only example of unsupervised learning that you're doing in this course. And there's another one that I would have liked to have covered if we had a little more time, and that's association mining. But clustering is a very commonly used data mining method. It's unsupervised in the sense that there is no target variable. It's unlabeled. The data is completely unlabeled, and you let the data do the talking. Basically, the data tells you what patterns are there in it. So the application that was given to you is it's an airline frequent flyer program, and you are given various attributes of the customers, and you're asked to cluster them, find out what is there any natural grouping of customers so that you can manage your frequent flyer program. Like most programs have, elite and platinum, gold, silver, and all of that stuff. So here also the process is fairly simple. So you retrieve the data. Again, I'm not sure what select attributes is doing here. I think the data was given to you in a form. There were no redundant columns, if I remember correctly, but I could be mistaken. But the main thing is that you needed to normalize the data before you cluster. Otherwise, clustering can get out of whack. And then for performance, you had the DVI that was calculated, and the with the across group distances, the clusters. So and then you are asked to find how many clusters do you identify, and I think most, if I remember correctly, most groups got this identified 7 clusters as this is where the elbow is occurring between these two metrics, DBI and AWCD. This one is almost flat, so it's difficult to spot an elbow over here. But here it's easier to spot an elbow in this graph, and I think pretty much all teams, as I said, if I remember correctly, ended up identifying 7 groups, 7 clusters, I mean. Interestingly, one team went with, and I gave them credit for it, they went with the DBI index, and they said that since the DBI combines two different metrics, so they went with 2 clusters, okay, because they saw the biggest jump over here, so they chose 2 clusters as the identification. So they had an explanation for it. Fine. So the main thing I'm looking for is has the team understood the different metrics? What was their logic behind choosing one or the other? I may disagree with some of the arguments, but it was reasonably convincing that I said, okay, they should get full credit for it. So the comparison of the clusters, I think you were asked to. It was given in the question that you should reconvert the parameters back to the original metrics. Otherwise, if you use the normalized metrics, kind of hard to compare the clusters. Every team did it except one, if I remember correctly. One team just kept with the normalized centroids, which technically is nothing wrong but for purposes of identifying the characteristics of the different clusters, that's not so easy to do. What does that mean? Okay, so having the actual parameters in here is fine. Then and then you have the centroid graph also. Some teams put in the centroid graph, some didn't, which is fine. I don't think I explicitly asked for it. I asked you to use the centroids to do the comparison, but I didn't explicitly ask for the diagram, I think. So some groups put it in, some didn't. So, and then you are asked to sort of in brief characterize the different clusters and give them some descriptive labels that convey the sense of what is that cluster. Okay. So different teams gave different names to the different groups, but the main thing I was looking for is what were those characteristics? Okay, like a low average balance and bonus miles, suggesting infrequent flyers. Okay, or people less engaged with the loyalty program. So it was the quality of this description that made the difference between one answer than another. Okay, some were very terse, which didn't convey much in terms of what was defining that cluster. Some were were brief, but still very descriptive, very good explanation of, okay, these are the characteristics that make cluster X different from cluster Y. Okay. That's what made for the differences in the quality of the answer. So I just picked out different descriptions of these clusters from different teams. Okay, so this was the centroid diagram for the team that picked two clusters that use DBI. So, and I can see why they did that, because if you compare this centroid diagram with the ones that most groups use, this one, okay, so you can see that some of the characteristics, like this one, I can't read what it is, but it's not very discriminating at all. I mean, the centroids are very close together, you see? So this is not telling you a whole lot. Same thing, here is not so bad. Here also, most of them are pretty close, okay? So not all the characteristics are equally good in terms of discriminating across the cluster. So the team that used DBI ended up with the centroid diagram. You see they're fairly far apart across the different dimensions, except maybe this one. So that was their logic, and I said that seems perfectly reasonable. And okay, so what? Now remind me, what was the? I forgot what the. Give the names. Yes, pre-process the data, and then after you pre-processed it, compare the characteristics of the cluster. Okay. So in terms of pre-processing, there were different suggestions that were made by the groups, and one thing that very easy thing to check for is, were there any outliers? Are there any outliers for any of the, because outliers affect clustering fairly severely. Okay, so one thing to check for is outliers. Okay. Couple of groups identified attributes where there were a lot of zeros. Okay. So if you have a lot of zeros in a particular column, when the majority of the values are zero, then they're not discriminating across the different clusters a whole lot. One team ran correlations across the different attributes. And what they did was variables that are correlated. I think they found 2 pairs that were correlated, and they turned that was an excellent thing to do. So they simplified the set. So removing redundant variables, removing outliers. These are standard things that you could have looked at. Okay. The other thing that could have been done, let me see if I have, oh, I didn't copy that. I was not completely feeling well at the time, and I didn't. So let me just, you will note, you can check this on your RapidMiner processor. Just like you have the decision tree, you can present the tree in the text form that you presented in the homework. Another way in which RapidMiner presents the clusters, I'm sorry, not the decision tree, the cluster. One way in which RapidMiner presents the cluster is in the form of a tree with circles, and the size of the circles is the size of the cluster. Okay, so when you have 7 clusters, what you will notice is 3 of the clusters are big. That means there are a lot of values in them, and the other 4 are very, very small. I don't remember how many were in each cluster, but maybe there were 3, 4, 5, 6, but very few. You could see the sizes were very small. That is usually a hint that there is some kind of outliers in there, in those. Okay, so what you could have done is trim those out and see what kind of clusters that you get in terms of pre-processing. I mean, because otherwise, those few values can distort the formation of clusters. So there are several different things that you could have looked at. The main one, of course, is outliers and correlated variables.
Professor, in that one, in the real world thing, if you have, maybe it's only a handful of frequent flyer mile people, is it really fair to trim them out? Like, what does that do to your business if you?
Good. No, absolutely fair point. Now, for instance, United Air, you may have come across this article maybe a year ago. United Airlines has one frequent flyer out of all its millions of frequent flyer, has one individual who flies more than a couple of million miles a year. Okay, so this person would be in a cluster all, but certainly you don't want to.
Cluster of one.
Yeah, more cluster one. So certainly you don't want to ignore that. So I'm not saying that just blindly take that cluster out with 5, the small size. I'm saying it's something to look at. That maybe that's a defining cluster. What are the characteristics? Okay, it could just as well be the reverse, that these are customers that are just have barely any association with the airline, and if you're trying to manage a frequent flyer program, then it doesn't hurt to drop them. So no, I wouldn't say just blindly drop them, but just from a clustering standpoint, when you see that kind of a pattern, that's cause for inspection. Why is that? Why is that happening? And I remember there was a team put in that picture with the clusters, big circles, 3 big circles, and then a bunch of small ones. And that was their basis for doing some kind of pre-processing. So that's what sticks in my mind. Okay. Another thing to look at, okay, this is a more a managerial issue than a technical one in terms of what should be the value of K. So yes, we did the elbow method and we came up with 7. Okay, fine. If you think of from the airline standpoint, managing 7 groups of frequent flyers, even 7 categories, is pretty tough, distinguishing between 7. Most airlines have no more than 3. Okay, at the most 4. 4 is probably the nobodies, and then 3, and then you have 2, and then 1. So in coming up with the K, there has to be some kind of balance between what the technical solution is and what the managerial implication of that solution is. 7 might seem like the right decision to make technically from a clustering standpoint, but it may not be the right decision managerially. Okay, so the managerial, they may say, hey, we can't manage more than three categories. Then you recluster based on run the k-median k-means algorithm, putting k equal to 3. If management already tells you that they can't manage more than 3 groups. Okay, let me see. Okay, so let's okay, then the question 2 was about grading. It's an application that everybody should be familiar with. So first part was, if a professor plans to use clustering k-means specifically to determine, you know that to use the k-means operator, the number of clusters must be specified in advance. How should the professor decide? So I got very valid answers for this one. And briefly justify your choice. The most common answer that I got was, the school has a grading scheme. It's A, B, C, etc. So if there are 5 of them, use 5 of them. Then, or if it has this, I don't know, 7 level with plus minus, then use 7. So whatever the university scheme is, that's fine. So far, so good. Okay, briefly justify your choice. The other thing, you could make a slight variations on that. For instance, in a graduate class, even though officially it allows for 4 grades, typically, professors, they know based on the background of the class, unless they are students with experience and so forth, that you really shouldn't, if you force a A, B, C in a graduate class, the algorithm will come back with 3 clusters, and somebody will be put in that C group. But is it really valid given what you know about the class? So something that the professor knows about the class might prompt the professor to use less than the allowed set of options for the grade that the university allows. So there are some nuances that you could have put, one could have put on that particular answer. So for part B is the alternate, it is the straight scale. Discuss the pros and cons. Again, in discussing the pros and cons, some of the justification given make perfect sense. That the straight scale is more understandable to students. They know where they stand in terms of grading as soon as they see the number. Whereas with the means, if you use k-means, they won't know exactly where they stand. It's always relative to somebody else. Okay, and it could happen that the whole class grade is between, let's say, 93 and 99, and still somebody ends up with a C if you use let's say 3 groups. Okay, that may not be fair. Whereas with this one, what's the weakness of the straight scale? The weakness of the straight scale, let's say for an exam, if for some reason the exam was not set properly, or it was extraordinarily easy or extraordinarily difficult, then everything, there's no option to adjust for that in the straight scale. So some circumstances where the k-means can be more judicious is, number one, if it's a new course where you don't know patterns of performance. If the professor doesn't know patterns, historical patterns of performance, then using a straight scale might be a little harder to do. If the professor themselves are new, they haven't had the experience of grading and they haven't had a lot of grading under their belt, then having a straight scale may disadvantage the students in some form. So just the novelty of the course, the experience of the professor are also factors in which one is appropriate. And so you may have noticed that in your own course 738, I'm using a mixture of the two. So in the sense that I've given some band for a fixed score, but within that band, the pluses and minuses are decided by clustering. So I've used a mixture of the two in our own course. So the reasons that were given were pretty similar, were valid. The difference between a high quality answer and a lesser one was the discussing the pros and cons. When is that made the difference between, and that was what was the difference I saw between a strong answer and a not so strong answer. Okay, so that's what I had by way of review. So now I'm happy to take any other questions that you may have, either about the homework or project or what have you.
I have more question about the final.
Yes.
Should we expect to run RapidMiner models?
Yes.
Okay.
You will have to build RapidMiner.
So, Professor, for the final thing, so all we do is just the RapidMiner, or you can use any other platforms like R Studios or Jupyter kind of thing to.
No. It's only RapidMiner. So and the problem will be very much like your homework. So some setting will be described to you, and you will have to build some model, some problem setting. Here's the decision that needs to be made. You will analyze it, and then you will have to use some method, and you will develop your model with the data set that's given to you, and then you will have to interpret the results and give a recommendation. This is what I recommend. Should be done.
No, I'm asking about our final project actually.
Yes. Oh, the project, not the final exam.
No, the project.
So what's the question about the project? I'm sorry, I misunderstood.
Is it just the RapidMiner we can use, or you can use any other platform like R
No,
Studio?
you cannot use any other platform, only RapidMiner, because otherwise I can't check it.
Okay, so the final exam would be just you will be giving some questions, some models, and you need to evaluate them.
No.
But for the final exam.
Yes, for the final exam, it will be like the assignments that I just gave you, that I just discussed. So you will be given a verbal description of a problem setting.
Okay.
And you will build a RapidMiner model for it. And then you will interpret the results, just like you're doing for every assignment.
And will there be some multiple choice as well? Do we need to?
No.
The quiz?
There's no multiple choice. So I think if you, for the final exam, to prepare for the final exam, if you went over your assignments, just reviewed what were the assignments,
Okay,
should be in reasonably good shape, I think.
great.